Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are studying the course lecture mathematics theory. This is lecture number 2 for class MSc part 2. I am your instructor Jamshid Alam Khan. Today the topic which we are going to study is current density and equation of continuity. Let us consider a conducting system consisting of one type of charge carrier, say Q. We are going to focus only one type of charge carrier. Number of charge carriers per unit volume is represented by n, capital N, and the velocity, actually known as the trip velocity, with which the charge carrier will move, is represented by v. Here in this case, we ignore the random thermal motion of the charge carriers. Let us now calculate the current through an element of area dA. As you see in this figure, charge carriers are represented by positive sign. All the charge carriers are only positive charge. Moving from this line to this line, and here we draw a normal unit vector perpendicular to the surface area dA. This charge carrier will cover a distance from this line to this line. During the time delta t, each carrier moves a distance s is equal to v into delta t. Here you can see s is equal to v into delta t. Delta q is the charge that crosses dA during time delta t. And this delta q can be written as q times the sum of all the charges in that volume. Here the volume is written as the product of S in dA. S is replaced by V into delta T, and dA in vector form it is represented as V vector dot n unit vector into delta T and dA. Here n is the normal unit vector drawn on the surface. Now, as in the previous lecture we studied the current and its basic definition, mathematically current can be written as dI is equal to delta Q over delta T. Here delta Q is replaced by N into Q, means the charge enclosed by that volume. This remaining term is known as volume divided by time delta T. dI is now n into q v dot n to dA. Remember, this equation is for one type of charge carrier. If a system consists of multiple charge carriers, then this equation is written in this form. dI is equal to summation I ni qi vi dot n into t. Here the summation is over the different carrier types. The bracketed term in this equation has a dimension of current per unit area. Current per unit area is known as the current density and is represented by the symbol J. J is equal to summation I ni qi and vi. J means current density has the following characteristics. Can be defined at each point in the conducting system, and it is a vector point function. Its unit is ampere per meter square. Now, equation of current in terms of current density is written as dI is equal to J dot n into dA. Now, integrating on both sides, I is equal to integration over the surface S J dot n into dA. This equation is for current through the surface S of arbitrary shape of a macroscopic size. Now, I am going to establish a relationship between current density J and the charge density rho. These two terms are not independent but are interlinked with each other. This relation is represented by differential equation, and that differential equation is known as equation of continuity. Whereas the origin of equation of continuity lies in law of conservation of charge, stated as charge can never be created nor be destroyed. Let us consider a volume V enclosed by the surface S, and the current is flowing inward to that volume V. The above equation of current, this equation, is now written in this form: minus integral closed integration over the surface S J dot n into dA. Here the negative sign shows the net flow of charge from outside of the volume to the inside, because we want to take the current I as positive. Here in this equation, n is again the normal unit vector drawn outward to the surface. In this equation, we are going to apply the divergence theorem. Divergence theorem stated that a surface integral can be converted into a volume integral. So minus sign is as it is, and surface integral is now converted into a volume integral, and J dot n into dA is replaced by del dot J into dE. Keep it in mind this equation, because in the next section I am going to develop an equation, and finally we will compare that equation with this equation. We are familiar with the basic definition of current. I is equal to dq over dt. Here q can be replaced as rho into dV, whereas rho is equal to q divided by v. This is the definition of current density, means charge per unit volume is known as current density. Here in this equation we have a fixed volume, and this time derivative d over dt is applying on the current density rho, which depends both on time as well as on position. So this equation will modify as integration over the volume V partial rho over partial t into dV. Now compare this part of equation with the above equation, this equation. By comparing, we have this sort of equation: integration over the volume partial rho over partial t into dV is equal to minus integration over the volume del dot j into dV. Put this term on the left hand side. Now by taking common the integration over the volume V and dV, the bracket term is partial rho over partial t plus del dot j. Here this equation holds for arbitrary volume of the medium. So the integrand or the bracket term must vanish at each point inside the volume. So partial rho over partial t plus del dot j is equal to 0. This equation is known as the equation of continuity. Thank you.